Dear students of class 9 and class 10, especially class 10, welcome to your mathematics class. Today we are going to discuss about trigonometry. You know that from previous 4 classes I am discussing on model creative questions and answers on trigonometry. So in that consequence, today we are going to step on part 5 of this video. I hope that you have participated in the uh, previously uploaded 4 videos. Now, in this video, we are going to be introduced with a new type of question. I named it type 2, and this type 2 question will be will be a little bit different type of question from the questions we have solved in our previous 4 classes. So in this class, uh, we are going to discuss about type 2 questions. Question type 2, in this type of question, you will have sides or ratio between some pair of sides or ratio between some pair of sides of any right angle triangle will be given. Sometimes an acute angle of a right angle triangle is given. You might have to express some trigonometric expression with the help of the given ratio, or might be asked to simplify some expressions. Sometimes it is required to find out values of some trigonometric expressions. So in this type of question, you will be given some acute angles or some right angle triangle or some ratio between two sides of a right angle triangle. And like this, there will be information regarding a right angle triangle, and you will be asked to solve some trigonometric expression to simplify the expressions, or express one equation on one expression in the form of other expressions, like this. So let's take a view. uh, Before it, we will have to know what is the prerequisites of solving this type of questions. So as the prerequisites, you will have to have knowledge about the trigonometric ratios, such as skill of expressing a trigonometric ratio using sides of right angle triangle. And what does this mean? And this means, like, you have to write down the things: sine theta equal to perpendicular by hypotenuse, like this. And skill of applying Pythagoras theorem to find out the other sides using two sides. If you have any right angle triangle, and if you know the length of any two sides, you have to learn how to uh, calculate the other side using these two sides, like hypotenuse square equal to perpendicular square plus base square. And therefore hypotenuse equal to root over uh, perpendicular square plus base square. So like this, you have to know how to calculate the third side if two sides of a right angle triangle are given. And then you have to memorize the trigonometric values, such as for 0 degree, 15 degree, not 15 degree, you don't need to memorize 15 degree. uh, you have to learn 0 degree, 30 degree, 45 degree, 60 degree and 90 degree. These type of values will help you to calculate triangles, or to simplify triangles, solve some triangles. And also this will help you to uh, have some insight of the solution process. So I highly recommend you to memorize the values for 0 degree, 30 degree, 45 degree, 60 degree and 90 degree. You may have looked at the table I have given you in first class. Also, you can have this table in your textbook. You can have thumbs rule or finger. Uh, you may have the technique of remembering the uh, values using your fingers. You may have searched in YouTube for different type of techniques to remember these values. So you must have to know that sine 30 degree equal to half, or cos 30 degree is equal to root 3 by 2, tan 45 degree equal to 1. Like this, you have to know all the values for these particular angles. And also you have to know the basic calculation skill of algebra, algebraic fraction, and calculation skill of root over sine involved expression. When often you will have some expression which are involved with root over sine, and you must calculate this kind of uh, algebraic expressions. So you have to learn how to calculate uh, under the expressions under root over sine. And you have learned this in previous class, that sometimes in type 1 question we also have to calculate under root over sine. So this skill is very important for mathematics and as well as for trigonometric question and solving. And I am giving some simple examples, or I am giving you some very common examples for creative questions. Many of you may be bored for this type of simple questions, and you may have the question in your mind that why our teacher is discussing about very simple and easy questions which we already know how to solve. I am asking you that, I am telling you that, believe me, there are some students in your class who cannot solve this math by themselves. So I have to take care of all my students, like weak students and medium quality students and high quality students. So I am giving you I am when I am discussing my class, or when I am preparing this video, I am keeping in mind that all kinds of students will see this, and I am making sure that um, I am trying to make sure that mm, you all of you can understand this very easily. I am not going to very tough stuffs. I am not stick with very easy stuffs. And always you can see that I will try to make you skillful, how to think, about how to think, and how to train our brain to think when we are going to solve trigonometric problems. Not only trigonometric problems, if you see these classes, you can also have some techniques which will help you in solving other maths also. So I think you will be very careful and attentive in these classes. So today we are going to take an example. As example, we have taken question 4. You can see here as a stem, it is given that the hypotenuse of a right angle triangle is root over 1 plus b, and adjacent side of the acute angle theta of the triangle is root over twice b. Now you are to find out another side of the triangle using the information of the stem and using a geometric figure. You have to use a geometric figure to solve the triangle or find the other side of the triangle, and also find the values of sec square theta plus tan square theta in terms of p. So you have to express these terms in terms of p, that is sec square theta plus tan square theta will be some expression regarding P. And also you have to prove that 1 plus cos square theta divided by 1 minus cos square theta is equal to minus 1 by P. So now we are going to solve this. You know, first we are given that the hypotenuse of a right angle triangle. So we have to draw a right angle triangle where the hypotenuse is root over 1 plus P. So we have drawn for solution we have drawn a right angle triangle root over 1 plus P, and also an adjacent side of the acute angle theta of the triangle is root over twice P. So this is our acute angle theta, and this is an adjacent angle root over twice P. Now we have to find out the another side. So AC is the other side. So your task is to find out the value of AC in terms of P. So you know that relation from Pythagoras theorem, you can you might be you might from Pythagoras theorem you know that here AB square equal to BC square plus AC square. From Pythagoras theorem, you may know, I believe you know that from Pythagoras theorem, you can write this AB square is equal to BC square plus AC square. Now put the value of AB and BC and find the value of AC. So from this equation, do it by yourself, pausing the video, then see the next item I show you. So I believe you have tried by yourselves to solve this problem, solution of problem 4a. Pausing the video. Now come back to my solution. How I could do this? So as I am asked to draw or construct a geometric figure, I have written that figure 1 is drawn according to the information given in the stem. Figure 1 is drawn according to the information given in the stem. Here the hypotenuse AB is equal to root over 1 plus P, and adjacent side theta side of theta is BC equal to root over twice P. I have written this thing as a uh, formality of drawing any figure. If you draw any figure in any question, if you are asked to draw any figure in any question, you just write down a description of the figure under the figure. This is a formality. This is not for marks. This is to clarify what you have thought about the picture or what you have thought about the diagram. So this is very helpful. If you go to write this, you may find out some problem in the figure to make it correct, and also this gives a good impression about you for about you to the examiner. So next, using the Pythagoras theorem, we get AC square plus BC square equal to AB square. We know that perpendicular square plus base square equal to hypotenuse square. Therefore, we are asked to find out the length of AC. So AC square equal to AB square minus BC square. So AB square, we put the value of AB. So root over 1 plus P whole square minus root over 2P whole square, will get 1 plus P minus 2P, and then 1 minus P. Therefore AC square is equal to 1 minus P. Therefore AC equal to root over 1 minus P. This is our answer. We were to find out the length of AC, and we have found that AC equal to root over 1 minus P. So this is our answer. Now we are going to solve problem number 4b. In problem 4b, we have seen that we are asked to find the value of sec square theta plus tan square theta in terms of p. So we have to express this equation in terms of p. So p is involved with the sides, so we have to express sec theta in terms of the sides and tan theta in terms of the sides. So we already know what is the base here, what is the perpendicular here, and what is the hypotenuse here. So we can write that sec theta is equal to inverse of cos theta. So we can say sec theta is equal to hypotenuse by base, that is root over 1 plus p divided by root over twice p, and tan theta is equal to perpendicular by base, that is root over 1 minus p divided by root over twice p. So let's see what we have to do is, so you may pause the video here and try to solve the question by yourself, and then check it out what is my technique to solve this problem. So I'm sure you have tried it by yourselves, and let's see what is my technique to solve this kind of question. So from figure 1 we get that sec theta is equal to hypotenuse by adjacent side, that is hypotenuse by base, that is AB by BC, AB equal to root over 1 plus P and BC equal to root over twice P, that is the we have taken the ratio of AB and BC. And also tan theta is equal to opposite side by adjacent side, therefore we have taken the ratio, and we have put the value of AC and BC in this fraction. And where from where do we get uh, root over 1 minus p as the value of AC? It is not in the stem, therefore we have to mention that from problem 1 we get that AC equal to root over 1 minus p. Now the given expression equal to sec square theta plus tan square theta. So we if we put the value of sec theta here, then we will get root over 1 plus p by root over twice p whole square plus tan square theta means root over 1 minus p divided by root over twice p, and as there is a square over 10, so we have to put a square over this value. Now you can see that squaring the fraction, the root over will be cancelled and root over sign will be cancelled, and we will get 1 plus p by 2p plus 1 minus p by 2p. So the LCM of denominator is 2sp, and as the numerator we will get 1 plus p plus 1 minus p, and 1 plus this will cancel, p and p will be p and minus p will be cancelled, and as the denominator we will have 2p, and as the numerator we will have 2. 2 and 2 will be cancelled, so we will get 1 by p, which is the answer. So we have got that sec square theta plus tan square theta equal to 1 by p. So now we are going to solve problem number 4c. We have to, as 4c, we have the problem as left side we have 1 plus cosec square theta divided by 1 minus cosec square theta, which is equal to minus 1 by p. We have to prove this. As left side we have 1 plus cos square theta divided by 1 minus cos square theta, as right side we have minus 1 by p. So we have to express this cos square theta or cos square theta in terms of p. Then we have to simplify or calculate the expression which will lead us to the right side. So I think you can take an attempt to solve this question by yourself, pausing the video, and after solving the question come back to the video and see what happens here. So I'm sure that you have tried to solve the video by yourselves, and you have solution of to problem 4c. We have to prove that this 1 plus cos square theta divided by 1 minus cos square theta equal to minus 1 by p. So from figure 1 we have that cosec theta equal to hypotenuse by opposite side, that is AB by AC equal to root over 1 plus p divided by root over 1 minus p. Now cosec square theta equal to 1 plus p divided by 1 minus p. Now if you put the value at the expression of left side, you will get 1 plus p by 1 minus p divided by 1 minus 1 plus p by 1 minus p, and then you can have 1 minus, have the LCM at the numerator is 1 minus p, and you will get 1 minus p plus 1 plus p divided by 1 minus p as the numerator, and as denominator we will have 1 minus p minus 1 minus p divided by 1 minus p, and after calculation you will get 2 by 1 minus p into 1 by p divided by minus 2p, and after cancellation 1 minus p and 1 minus p and 2 here, you will get minus 1 by p, which is the right side, which is the right side. Right side. So hence the problem is solved or proved. So this was very simple example of type 2 question. We have another question of like type 2, which is question 5. We have here cosec theta equal to root over 1 plus x divided by 1 minus x, and we are to express sine square theta in terms of x. We have to show that tan theta is equal to root over 1 minus x by twice x, and we have to prove that sec theta minus tan theta divided by sec theta plus tan theta equal to 1 minus root over 1 minus x square by x. Now I want all of you to solve this math by yourself, and then come back to the solution what I give to you, and match whether you have done the right thing or wrong thing. I'm sure that you have tried by pausing the video. Now we are going to solve this problem in my way, in your teacher's way. So solution of problem 5a. Express sine square in terms of x. So given that cosec x equal to root over 1 plus x divided by 1 minus x. So what is sine x? Sine, you have to express sine square x. Sine x will be 1 by cosec x. So sine square theta equal to 1 by cosec square theta equal to 1 by, put the value of cosec theta here and put a square here, and square and root will be cancelled. Then 1 by 1 plus x divided by 1 minus x is equal to 1 minus x by 1 plus x, which is the answer. Very easy. Now solution of problem 5b. We are given that cosec theta equal to root over 1 plus x divided by 1 minus x. Now for b we have to express tan theta in terms of x. So we will introduce a triangle here. This triangle is often called auxiliary triangle. So now you can construct an auxiliary triangle as follows. You can see that we have taken a right angle triangle ABC as the auxiliary triangle, and we have cosec theta. So we know that cosec theta equal to hypotenuse by perpendicular. So we have taken 1 root over 1 plus x as the hypotenuse here, as hypotenuse, as the numerator is 1 root over 1 plus x, and as the denominator is root over 1 minus x, and cosec theta relates with a triangle like hypotenuse by base, sorry, hypotenuse by perpendicular. So we can take this denominator as perpendicular in the auxiliary triangle. So in the auxiliary triangle we have hypotenuse is root over 1 plus x from the numerator of cosec theta, and the perpendicular is 1 minus x, root over 1 minus x from the denominator of cosec theta. So from this we can calculate the value of BC. We know hypotenuse, we know the perpendicular, now we have to calculate the base. So we will use the theorem of Pythagoras, and we can write this like BC is equal to root over 2x. So how can we find it? We have to give the calculation here. Since cosec theta is equal to hypotenuse by opposite side equal to root over 1 minus x divided by root over 1 plus x, here we have taken hypotenuse AB equal to root over 1 minus x, and opposite side uh, AC equal to root over 1 plus x. I have explained it this line before. Now I am writing this line as a formality. Now using Pythagoras theorem, we can calculate BC square. BC square equal to hypotenuse square minus perpendicular square. So hypotenuse square equal to root over 1 minus x whole square minus perpendicular square equal to root over 1 minus x whole square. So which will lead us to twice x. Now we can write that BC equal to root over twice x. Now you can see we all know what is the hypotenuse, what is the perpendicular, and what is the base of the auxiliary triangle. From this triangle we can see tan theta is equal to perpendicular by base, that is root over 1 minus x by root over twice x. So from here we can write that therefore tan theta equal to opposite side, that is perpendicular, divided by adjacent side, that is base, equal to AC by BC equal to root over 1 minus x divided by root over twice x, which is whole root over 1 minus x by twice x. So this is the value we have expressed tan theta in terms of x. So this is our solution to problem 5b. There is another method to solve this problem, but I personally prefer this kind of problem, because this kind of solution, because this solution leads you to go to the basic, uh, that is right angle triangle, drawing a right angle triangle and then solving the problem. Now we are going to solve problem number 5c. For 5c, we are to prove that 5c, we have to prove that sec theta minus tan theta divided by sec theta plus tan theta equal to 1 minus root over 1 minus x square divided by x. There are several methods to solve this problem. Now I am going to take help of the right angle triangle to solve this problem. Now in my method, or my preferred method, the method I prefer uh, to use the auxiliary triangle. So from the auxiliary triangle we have drawn in 5b, we can copy it here like this: ABC equal to hypotenuse is 1 plus x root over, and perpendicular is root over 1 minus x, and base is root over twice x. So we can write, we can see that in 5c we have two expressions, trigonometric expression, tan theta and uh, sec theta. So we can write that tan theta equal to root over 1 minus x divided by twice x, which we already have in 5b, and sec theta equal to hypotenuse by adjacent side. Sec theta, we know that sec theta is opposite to cos theta, therefore as cos theta is base by hypotenuse, so sec theta is hypotenuse by base, and another name of base is adjacent side. So sec theta is equal to hypotenuse by adjacent side, and put the value of hypotenuse and adjacent side, you will get root over 1 plus x divided by twice x. Now our expression is sec theta minus tan theta by sec theta plus tan theta. So for this expression you will get if you put the values here, you will get like this, and after putting the value, distribute the root over sign in denominator and numerator, and then you will get this sign, this expression. I can write it, make it bigger for you, and then you will get, when you add by taking LCM of the denominator, the fraction will get, the fraction expression will get like this. Root over 2x is the LCM of denominators which are in numerator of the total fraction, and you will get the numerators subtracted from each other, and also like this. And from this you can write, as this is a division and this is the numerator and this is the denominator, and if you take the denominator as multiplication, it will be reversed, and therefore root over twice x will be go as numerator, and root over 1 plus x plus root over 1 minus x will get as the denominator. This fraction will be flipped when it is multiplied, when it is come as multiplication instead of division. So 2x, root over 2x and root over 2x will be cancelled, as the denominator will get root over 1 plus x, and root over 1 plus x minus root over 1 minus x divided by root over 1 plus x plus root over 1 minus x. And as a consequence we have got this, and now we are to prove that look at here, question 5. Look at here, we have to prove that 1 minus root over 1 minus x square. As the numerator we will have to have 1 minus root over 1 minus x square, and as denominator we will have to make sure that there is an x as denominator. So for this we can write, we have to remove the root over sign from denominator and numerator. We have to remove this form, and we have to get simplify, we have to make it simplified. So if we multiply the denominator and numerator with the we have to multiply both of the numerator and denominator with root over 1 plus x plus root over 1 minus x. If we multiply this, we have to multiply root over 1 plus x minus root over 1 minus x and divided by root over 1 plus x plus root over 1 minus x. We will multiply both of the denominator and numerator with the numerator, that is 1 plus x minus root over 1 minus x. If we multiply the numerator with the numerator, it will become a whole square form, and as the denominator and the multiplied term are opposite sign, so we will get as denominator root over 1 plus x plus root over 1 minus x into root over 1 plus x minus root over 1 minus x. So this is our remember this, from this step to this step we have to we have to multiply the both of the numerator and denominator with the expression which is in numerator. As a result, the numerator will be at whole square form, and in the denominator we will get an expression of the form a plus b into a minus b form. So in as a result, you can see as a whole square we can put a formula here, a square minus 2ab plus b square. So root over 1 plus x whole square minus 2 into root over 1 plus x into root over 1 minus x plus root over 1 minus x whole square here. And as a denominator we can put the formula root over 1 a square minus b square, so root over 1 plus x whole square minus root over 1 minus x whole square. And by this you can simplify it like this, as you have got square over root, so root and square will be cancelled, and this square and root will be cancelled. You will get 1 plus x minus 2 into root over 1 plus x into root over 1 minus x, and 1 minus x here by cancelling root and squares. And as the denominator will get 1 plus x minus bracket within bracket 1 minus x, and by this you will get this. You can see as in the numerator plus x and minus x will be cancelled, plus 1 and plus 1 will be 2, and 2 into root over, as these two terms are both under root over sign and are multiplied with each other, so we can take the root as whole root over 1 plus x into 1 minus x. And as the denominator will get, if you subtract 1 minus x from 1 plus x, you will get 2x. Remove the bracket using the minus sign, you will get 1 plus x minus 1 plus x. Minus 1 and 1 will be cancelled, and x plus x will be 2. So 2x, x and x will be 2x. So as the denominator you will get 2x. Now if you take 2 as common factor of numerator, you will get 2 into 2 into 1 minus root over 1 minus x square here, as 1 plus x and 1 minus x is equal to 1 minus x square. So 2 into 1 minus root over 1 minus x square, as the denominator will get 2x, and if 2 and 2 are cancelled, you will get 1 minus x, 1 minus root over 1 minus x square divided by x, which is the right side. So this is our proof. You can prove it in another method without using the auxiliary triangle. So this will be also a correct method, but I prefer this method for several reasons, uh, and I think this method is very interesting for you too. So this was our class for today. Thank you for attending this class very attentively, and keep your study on in your home, and keep preparing for your test exam and also for S.S.C exams. Practice a lot of maths to get skilled in trigonometric problems and also in other problems uh, which are very common in S.S.C exam. You have to do good result in the S.S.C exam. Also, you have to be a skillful student in mathematics. So I hope all of you will study hard, and all of you will do well in your examinations, and all of you will devote your life for acquiring knowledge and serve the peoples. Thank you all again. Best of luck with your practice.